So this is how I wrote for this slide. I started writing it, and then I realized I got to a point where I'm a little lazy, and I can just show you the code. But let me show you this slide first. Today, CloudStack's software actually are in different packages. It is to enforce a certain compilation package so that people don't misuse the code. So when you go look at CloudStack's code, you will see. Let me show you this. You will see a utils directory, and what that is anything that is common to any development platform. It's not unique to CloudStack. But today, our component injection framework, our database code, our database SQL generation code, and things like that are actually in the utils package, and our searching is in the utils package. The second package that you might be interested in is the API package. So today, in this API package, it contains all of the REST API, all of the APIs that are sent to the resources, and the API that is that defines the plugins that CloudStack uses. Now, in general, all the code should be developed based on just utils and API. It shouldn't be based on core and server. So that's something that you need to be aware of. Core is, I think, going to be obsoleted soon. It used to contain all of our resources because remember I said earlier that in CloudStack's implementation, the resource cannot access the database. And each resource could actually be deployed within CloudStack or within CloudStack's management server or inside a remote agent. And so then it cannot depend. So let me see if I can come up with. So this is the picture, right? Down here is all of our resources, and these. Oh. Okay. So down here is all of our resources. So what we used to do is that we compile the resources before we compile the server codes to make sure that the resources cannot access the database. It's because, like I said, resources are meant to be deployed co-located with the physical elements that it controls. So then it may not have access to the database. And I actually want to add that I think during this phase, if you have questions, you should just ask, because just wave your hand and ask. Because if you wait all the way to the end, and I probably don't even remember what I was doing. Right? So that's core. And then there is server. So server is where all of our database access, our business logic, our orchestration logic today lives. So if you're interested in looking at that, you can go look at that component. And then for 4.0, we added the plugins directory. So plugins is not one single project. It's actually a lot of different projects because we move most of our plugins into this layer. So if you go into someone earlier was very interested in a deployment pattern, then you can see we actually have two different deployment patterns that ships with CloudStack. If you're interested in network elements, you can see these are the network elements that are in CloudStack today. If you're interested in I'm not sure what this is. This or not. File system is something that we added for NetApp. And here's the hypervisors. So basically, plugins, each one of these plugins is a project of itself because it should compile separately and it should be tested separately from CloudStack. And that's where we move things to right now. And like I said, a lot of these things were used to be in the core, but it no longer is. Is actually inside these plugin directories now. And you will find also AWS API, which is the compilability layer with EC2. There's the usage. Usage right here is is the usage processor that generates the usage records. There's UI, which contains all of our JavaScript, and then there is agent. And so this concept is somewhat different because, like I said, our resources are code that executes certain things. But the transport layer for communicating with the resource and being able to receive commands from CloudStack's management server is actually a separate code because this code is nothing more than establishing a TCP connection and being able to serialize and deserialize the commands and answers that are sent back and forth. And then it pipes that down to the resource code. So this agent shell is a separate project by itself. It hardly has anything in it except for the serialization and deserialization of management code. And then client is where we put our Tomcat configurations. Now, when you look at it, there should be a lot more than that. There's packaging in right here, which is different ways to package in Debian and Fedora, and developer is a bunch of tools that people have written. Console proxy is the code that does the proxying of a VM's console onto an HTML browser so that people can remotely control their servers. So is there any questions about this structure? So I think.
すみません。すみません。これコンソールプロキシがなぜ一番トップディレクトリにあるのかちょっと知りたいんですけれども。
That's a good question. I don't know why. Most of the time, the reason is because when we first wrote this, somebody just created that directly, and we haven't had time to move them into appropriate places. Whereas today, when you're doing CloudStack, you will find that CloudStack is still kind of in a little bit of flux in terms of its packaging. And so, let me see if I can. So I wrote, I think, this some time ago. Basically the same thing we see here. And let's show you the CloudStack package. So if you go to our wiki, basically you will find the same thing I listed here. But now you can also find this, which is our compilation dependencies. So we always compile Cloud Util first because this is the package that can be used anywhere. Cloud API, because this is where we actually define what CloudStack does, right? Cloud Core, and then you can see the plugins, Cloud OVM, VMware, Agent Simulator are all based on Cloud Core because that's where all the resources are actually in. And then Cloud Server is based on API, and Cloud Agent is also based on API. So you can see when you are in this layer, in the Cloud Core and Cloud OVM, you cannot access the database because you actually could be compiled before the server package. And then the server package then is only based on Cloud API. So it doesn't actually understand what happens inside each of these other packages. So this is a suggestion for the future that I should delete that because we're changing that. So maybe we can take a look at some of the code and what I meant by that. So now here you can see these are a list of the plugins. They're all each their own API, their own packages, right? And then there is the packages for the things that I showed you earlier. So let's take a look at. So I'm going to show you how, when you first, how to import all of these projects. So let's remove all these. So Eclipse is your friend. It will be your best friend when you're working in CloudStack. And the other friend that you're going to get in Eclipse, and you can download Eclipse, I think, and probably a lot of people know where it is once you download Eclipse, the first thing you should install is go to Eclipse Marketplace. It's a little slow, and I won't install it because I already have it. But go into Popular. And there's two things that you want to install from here. Oh, yes, it doesn't have one. Okay, so the very first thing you want to do is install this stack, which is the Maven integration for Eclipse. As CloudStack in 4.0 has completely moved over to Maven. And in master, there's even more work there for Maven. And then the second thing that you want to install is going to be a Git. So the eGit team provider, right? So because CloudStack's repo is in eGit, it is in Git, and if you're interested in doing Python development, then you should start Python. Now, once you've done that, then you can now go to import CloudStack's projects. And what you want to do is import Maven, existing projects. Put in the directory that you should go to. And it will go through and find all the palms for the projects and list it for you so you can import it. I'm sorry it takes a little while. I mean, I have an SSD in here, it still takes some time. So how many of you are actually working on CloudStack? So show of hands. I know you guys over there. Yeah. So which part are you using?
環境構築とか、あ、それマイクの。まあ、実際にいくつかのシステムを作っていきます。で、自分が今やってるのは、まあ、ソースコード結構読むこともありますし、あと今ちょっとこれ出てたんですけども、シーケンスを解析したりとしています。まあ、実際の仕事は、まあクラウドスタックを使ってシステム構築したり、さらに付加価値のあるような、システムを作ったりしています。
So, all right. So now this is set. Then now we're going to put the projects. I'm not sure why there's a problem with it. Okay, so now you see the projects are starting to come in. It's going to take a little while because Eclipse is going to, there's still more. And I guess Eclipse decides to install some software for me. And we still can browse. Okay. Let's go look at API. So the API section is the most important because that defines what CloudStack can do and what you can do in so when you're going through our API section, you should be here. This lists all the agent commands. So these are the commands that are being sent and to the resources, and you can look through them. You can also look through the actual APIs, which is the REST APIs that are being used. So this is the APIs when an end user wants to start a VM, or when our UI is talking to CloudStack. It all uses these APIs, and that's under the Cloud API package. And then for the interfaces that you want to see, for example, network elements will be here. So let's show you a little bit of this. So let's take. So I don't know if you remember from this morning's sequence diagram about how CloudStack actually shows broadcasts events to the network elements. But when a network is being implemented, it goes through this interface, and this interface we will call the implement and code method, right? When a VM is about to start, we will tell the network element, prepare for this VM to start. Now, if you have nothing to do with that VM, or you don't care VM starting, and then you just do nothing into it and don't handle it. When the VM is stopped, we will tell you that this VM is being stopped and the NIC is released from the network. So make sure you do the appropriate things to release. And when the network itself is being shut down, that means there's no more VMs running in this network, and CloudStack decides to garbage collect the network. It will call shutdown on this interface, and the network element should react appropriately. And when the end user decides to destroy the network, then this event will be called. And then we will also ask if the network service provider whether or not you are ready to take on new instances. And then you can also shut down that particular, shut down your code. So basically, there's information like that. And then we started building different services on top of that. So for example, this one, basically, if you implement this interface, then it allows you to add DHCP entries, and so that CloudStack will know, oh, this code can actually handle adding DHCP entries. As if you are doing port forwarding, for example, then CloudStack will know that, oh, this piece of code with this interface, I understand that this guy knows how to do port forwarding rules, and things like that, so forth. So a lot of the services here define exactly what, when you implement that interface, you're telling CloudStack, I know how to deal with this particular type of service. Any questions here? Okay. And so let me show a little bit of the network rule interface that I said earlier. So see this big long comment I put in here, and nobody ever reads it, but it's always there about what network guru does, because everybody just comes and asks me what network guru does. Remember earlier I said that network manager itself doesn't really understand what network is. It understands how to orchestrate it and how to use it, but it doesn't understand how to actually make the network. Because even for designing the network, we ask the network guru. So when it comes in and someone says, oh, I have this particular, I want to create this network with this network offering, and I want to deploy it to a certain plan, we will ask the network guru that you need to design it for us, because we don't know how to deal with that network. And then once it's designed, then CloudStack will store that into a database. And then we'll also store down the fact that it is this network guru who designed it for us, which would mean that you are now forever the parent for that particular network. And so then when it is time for us to say, oh, this network needs to be realized on the actual physical network, then we will also call that network guru and says, now you need to implement the network. The network on the physical switches and things like that. And when a VM starts, we will ask the network guru, you need to, when a VM is created, we will ask the network guru, you need to create an entry for me for the NIC, so that I can plug that NIC into the VM. And when it's time for the VM to start, we will ask the network guru, you need to reserve the network, IP address or whatever for this particular NIC. Same thing with release. We will release it when the VM is being stopped. And when the VM is being destroyed because the user doesn't want this VM anymore, we will come back to the network guru and says, oh, now you can deallocate this VM, deallocate this NIC because the VM is being stopped, being destroyed. That's obsoleted. So, and then you can shut down the network, which will ask you to do the work if it's necessary. And then you can trash the network when the network is completely destroyed. Now we can take a look at. Now, earlier today I talked about how virtual machine is different than user VMs. So this is our interface to a virtual machine. It represents virtual machines for us. And all of our virtual machines are driven by states. So there is an actual state system here. So this list shows all of the states that a virtual machine can be in. And if you follow here, we have an actual state machine that says, depending on what event you are and what state you are at, this will be the state that you will be at. So if you were stopped and someone requests to start, you will move into starting. You will move into the state start. But if you are in destroyed, and recovery has been requested, then you will move into start. So basically, we run our systems all according to this state machine, and changing the state machine is you have to be very careful about what you're doing. So for a VM, you can see you can get its IP address, get its host name, get its MAC address. Get its time, and get the time that it was created, and things like that. Now, Kimmy was showing you this morning, or this afternoon, this API. So let's say create remote access VPN. Now, this is sent using our query language, right? And you would like to follow how this actually is executed in CloudStack. So the way that you will follow it, first you bring up something called this has a list of all of the REST commands that comes into CloudStack. So you will find the create access. So create remote access VPN, the command. It is actually implemented by command class, right? So you So now you can see this is the command class that actually implements that command, and you can look that all the parameters that's here is actually all on this page. So account ID, domain ID, IP range are all on this command. So basically, the commands will come into this code right here. It gets parsed out, and this class gets formed, and then when you call execute, there will be an execute method here, and then you can follow the execute method. So you can put a breakpoint here and start debugging into CloudStack to see what it actually does for remote access VPN. And you can do that for every single REST API command that you have in CloudStack. Is there anything specific that you guys would like me to cover for this?
すみません、KVM のエージェントに対してコマンドを発行しているところを、知りたいんですけれども、そこに関するコードを見せてもらえますか。
Okay. So it's actually that's a good question, because I showed you the plugin API, I showed you the REST API, and I haven't shown you the resource API. And KVM agent will be one of the resources. So let's break that. So not quite strangely, network computing resource. So KVM's agent resource file is called libvirt computing resource. That's because it interfaces with libvirt. And you can always follow you can always debug it by looking for a method called execute request. And you can see these are the commands that this libvirt resource actually implements. And so the idea that when we develop resource, we didn't put a static, very static interface onto it, like we did with elements. And the reason is because we know that when you write the resource, oftentimes the resource is composed by a lot of different commands. Now, what do I mean by that? Because when you execute a certain command, it's oftentimes executed on that resource. And you have to be able to just create commands and answers without CloudStack being in the way and say, oh, the command has to be this particular way. So you basically just create commands and says, oh, I can execute them here on this resource. So let me show you. For any of the resources that CloudStack has, these are all of the things that CloudStack requires you to implement. Only these 5 or 6. Okay, what type of host you are? You need to give me a startup command when you initialize. You need to give me a ping command when CloudStack asks you to give me your current status. And then the meat of the work is in this method, which is execute request. Because by doing this, then the agent above the server resource does the serialization and deserialization, and it changes it into a command. And then it passes this command to the resource that's being executed, which then says, I know how to execute this command or not. If it doesn't, it throws an exception and says, I don't understand the command. But then what that allows you to do is you can add any command into any resource. Because someone who's actually doing networking, and like what we do with security group, may want to add a command on hypervisor because you actually are talking to a hypervisor to execute that command. And CloudStack itself doesn't understand that. Doesn't want to require that you have to execute the resource. So execute that security group command. So when you implement, you can just add them to this method. And the way that to add it is like, and you can see there's a lot of different resources in CloudStack. Basically for hypervisors, for Nicira, for network elements, and so when you are in here, then you just add a particular command into this list, and as long as it's been delivered to this, you can execute whatever you want. So that's the way that we build resource, because we expected resources would be composed by other people. Other people would be modifying this very, very quickly. So we do not want to put a static interface on it, like what we do with for example, something like make.java. Now here we have a very well-defined interface because people don't update this. They just use it. Whereas as resources, people update and make changes to it often. Does that satisfy what you're asking for? Okay. So let's take a look at how we compile it. I said Eclipse is your friend, right? And Maven is also your friend. And so I always install Maven because now it's absolutely required. So Maven on 3.04. This cleans the project. And hopefully I don't have to install any dependencies. And this will actually compile the projects. So we're gonna look at this for a little while. So is there anyone else who would like to share what they're doing with CloudStack? You guys? Cool.
ことでいいですか。So we're currently integrating MitoNet, MitoPress, SDN solutions with CloudStack. So we're working with Ubuntu with the KVM hypervisor. So the code you were showing just now is our friend, I guess. So yeah, that's pretty much it. Yeah, that's pretty much it.
Thank you. Yeah, it's not quite long enough for the compile process to finish.
We need to compile storage.
Let's take a look at some more what CloudStack does. So CloudStack is actually a system that's composed. And when you compose CloudStack, you first have to look at something called you have to first look at this file. Now, I don't know if you guys are familiar with AOP, a programming model, but what AOP says is that you don't actually know, you only know the interfaces. You don't actually know the implementations. And in CloudStack, the implementations are recorded by this component.xml. And you only tell CloudStack component system that, oh, I need an implementer of this particular interface. You don't go, oh, new the implementation. You just ask for that interface. And this is actually all inside components.xml. So let's take a look at that. So components.xml starts with a system integrity checker. These guys are run when CloudStack first starts. Now, why do you need that? Because you need to make sure that the system is actually at a state where CloudStack starting up won't create problems. And these are the things that it actually checks. Management server node checks, basically generates an ID for itself. Encryption secret key checker is something that creates an encryption key. So that the sensitive data is always encrypted with that encryption key. There's a database integrity checker to make sure that the database is at a level where you can actually run the management server. And then there's a database upgrade checker, which checks the database age version, and if it's at the wrong version, it will attempt to upgrade the database. There's a set of interceptors that CloudStack deploys, and I can go into that a little bit. But the meat of this file is going to be this management server. So the management server tells you what class has the management implementation, and then it tells you, oh, I have a set of libraries that you can that is being used to specify what are the components that are being created. So if you go and look at this, this tells you what are the DAOs, the DAO layers to use, and what are the managers that are being used in CloudStack. So if you're interested in exactly who implements and the bare metal VM manager interface, you come to here and it will tell you it's the bare metal VM manager info, in case you couldn't guess it yourself. And then this actually extends the default component library, which has more information that it can about how CloudStack is constructed. These are the classes that actually constructs CloudStack. So I think if you are familiar with Google Juice or Spring framework, Spring AOP framework, this is very similar. Now, you're probably not as interested in the managers and DAOs because those things don't change as often, and you don't really replace those classes as often. But CloudStack also has the concept of adapters, and an adapter is basically different ways to do the same thing. And because network elements are basically adapters, because they are different ways to implement events, handlers of CloudStack events. And so here is where you see most of our plugins, because plugins are basically adapters. And you will get host allocator, storage pool allocator, there's pod allocators, console proxy. Here's the set of network rules. Those that CloudStack deploys. You can see Nicira is one of them here. And then cluster servers, adapters. So this is basically the list of adapters I showed you before. And once you put it in here, then CloudStack will actually use it. Now, if you discover that one of the adapters is not working well and is causing problems in the system, you can just remove it from you remove it from this XML, then none of the code would actually be executed in CloudStack. When CloudStack loads, it will say, oh, this guy, you didn't specify the components XML, therefore I'm not going to load it, and it wouldn't be executed. So the other thing I wanted to show you is the idea of pluggable service. So you saw earlier that CloudStack's commands are basically all recorded in commands.properties. And this is the set of commands that CloudStack has. But like I said earlier, there's what if your plugins actually need their own commands? And so then there are people who write their own command properties. You can see it right here. So for example, F5 big IP has their own set of command properties. Adding an external load balancer, deleting an external load balancer, listing an external load balancers. And you can see, oh, these are the classes that implements this particular command. Adding F5 load balancer, configure F5 load balancer, things like that. And then now you can follow that and says, oh, what I want to see how it's implemented. And boom, you can see here's the parameters that it's supposed to have. And you can debug into it the execute method and follow that, and that will show you, how it's being implemented. So it's a very good starting point, because most of the time when you have a problem, you start with a request, and you just need to know what the request was, and you map it to the class, and then you go from the class in. And so I wanted to show you pluggable service. So pluggable service is actually very simple. You just have to tell us where your command.properties files is. That's all you need to tell us, because we will go load all the command.properties and do all the mapping for you. So let's take a look at who actually implements pluggable service. So for example, Cisco Nessus. This has a service. It extends it. So who implements this element? And let's see, where is the properties file? So it says, oh, get properties file. It's Cisco Nexus M properties. Nexus, oh, is this one right? Nexus VSM commands properties. And what CloudStack does when you tell us that, we will go through the Java class path and look for this particular file. Once we find it, then we will load all the commands in there, and that becomes commands that we extend. But those are the extensible commands that we put in the CloudStack. Does it make sense? Any questions? Let's see how compilation.
いいですか
先ほどディペンデンシーインジェクションのコンテナ A4P を自分たちで実装しているっていう話があったんですけど、あれっていうのは既存の例えば Google ジュースとかスプリングフレームワークとかを使わなかった理由っていうのは何かあるんですかね。なんか機能が足りなかったとか。
Well, I did injection dependency before that, when it was back in C++ and Allen days, COM days. So I just had this available and it was working. So I didn't really need to use dependency. Now there is a movement now in post 4.0 to switch this to go use Spring. And I don't know Spring very well now, but there's other people who's working to change it to Spring so that people know how to use it. Because right now, in order to use it, you have to understand how component working works. So it just I just didn't know about Spring. When
なるほど、分かりました。すみません。あともう一つお聞きしたいんですけど、例えば先ほどのKVM とかで使っているリブバートコンピューティングリソースとかは実際には KVM が動いているホストの中に入っていると思うんですけど、リソースっていうのはメッセージバスを介してマネージメントサーバーよりも外というか別の場所にあるっていうのは、普通というか、KVM が例外というわけではなくて、そういうことも通常あり得るっていうことなんでしょうかね。
Can you repeat? I'm not sure I understand.
例えばその KVM で使っている、リソースっていうのは KVM が動いているホストの上で、動作すると思います。でただリソースっていうのはマネージメントサーバーの上にいるわけではなくて、その別のホストのところで動いているっていうのも考えられるでしょうか。
So the KVM resource is running on the KVM host today.
はい。
And it makes a connection back to the management server. It's not on a different host. I'm not sure what you mean by that.
まあ、それはなんか自然なことっていうふうに理解すればいいんですかね。ちょっと質問がしにくいというか、なんて言えばいい何が言いたいかというとソースコード上はそれがマネージメントサーバー上で動くのかそれとも別のホストで動くのかっていうのが区別できなくてどういうふうにシーケンスが流れていくのかっていうのがちょっと分かりづらいなと思ってたんですよね。
Okay, I can't understand. So in CloudStack, the messaging layer is implemented by something called Agent Manager. Above the Agent Manager is always business logic. And when the business logic decides I need to send a command to a resource, it calls the Agent Manager to send the command. Now, the Agent Manager hides the fact that the resource may be deployed inside the management server. So for example, the sensor resource in general are deployed inside the management server, but the agent manager hides that. To everything above the agent manager level, it doesn't understand where the resource is. But the agent manager itself understands, and it says, oh, this particular resource is supposed to be on the management server. I'm going to load it inside the management server. But if it was a remote resource, then it is dependent on the TCP connection that makes it back to the CloudStack to determine that this is a remote agent. So for remote agents, then CloudStack does not know how to start it, you have to start it yourself, which then makes a connection back to management server. But for a direct agent, one that is deployed inside management server, the agent manager is the one that knows to start it without start it, and then it hides the fact that it's actually on management server. So we can actually take a look at that. So this is the agent manager. Like I said, this is actually the layer that hides all the messaging. So you can actually pull out most of this and replace it with something else. Now inside here, it understands. So inside here, it understands that certain resources are loaded by this particular host. And the way that it knows that is because for each type of host, there's something called discover. Now, if you look at the KVM server discover, it doesn't actually return a correct. So if you look at the KVM server discover, it doesn't actually understand that. It doesn't return the KVM resource. It returns what's called a dummy resource that actually starts the KVM agent on the host. See here, it makes the SSH connection and deposits the agent onto the KVM host. And then it returns, and agent manager will go, oh, this is not a direct loaded resource, so I'm not gonna start it. But if it was a sense server discovery, so when you make the call to add host command, it eventually makes its way down to the discover, and then we go through each discover and says, oh, is the host that you're trying to add, is it KVM, or is it sense server, or is it VMware? As long as you add a discover into here, we will figure that out, because the discover will come back and says, yeah, I know this particular server. And you should use this particular resource to talk to it. Now, so XCP Discover then says, I know how to, I know it is a sense server resource. And let's see what it does. So in the discover, we make a connection to that particular sense server, and then we try to figure out what version this sense server is, because each different version of sense server requires a little bit different resource to talk to it, because the API changed a little bit from one version to version. So you need a different version to talk to it, and so you see this code that says create the server resource, which then says, well, if it's XCP and it's 1.0, then we turn the XCP resource. If it's 5.6, we turn sense server 5.6 resource, sense server 6.0 resource. So let's take a look at these guys. Now you see, sensor 5.6 resource is actually a very small file. It's literally 360 lines. It is able to be that small because the majority of the code is actually in the parent class. Because this parent class is much larger because it needs to deal with security groups and different things. It's 7,000 lines. But so sensor 5.6 resource that only implements just a little bit of difference between 5.5 sensor resource and 5.6. And then there's also a resource. And this one would be even smaller. This one is 200-300 lines of code. And it implements only the difference between 5.5 and 5.6. 5.6 and 5.6 FP1. Now, the discoverer goes in and says, yeah, I understand it's sensor, and I understand its version, and so I'm going to return you with different versions of this resource. And when it returns, it also says, oh, also, this guy is loaded directly. It should be loaded inside the management server. And when that happens, then the agent manager says, this resource I have to remember to load, and I should load inside the management server every time. But to everything above agent manager, if you were for any of the orchestration code for that is trying to talk to that particular sensor resource, it doesn't understand that. All it understands is I'm sending a message to one particular host, and agent manager will route it to the correct host. Does that answer your question?
つまり、エージェントマネージャーは意図的にそのリソースがどこにあるかみたいなのを隠しているっていう理解であってますか？
Yes, that's absolutely correct. Because you don't really want the business logic to change just because the resource is hidden inside the management server. Then you actually have to write a lot of code that says, if it's this way, do this, else do that. So we hide all that. We abstract that away from the business logic. So if libvirt can actually accept commands out from the outside and can actually execute the scripts that we put onto KVM, the libvirt resource could actually be deployed inside CloudStack too. That's actually very possible to do. But today we execute a lot of shell scripts on KVM, and KVM itself by default does not have anything that can dispatch plugins and dispatch shell scripts. So then that's why we put the agent as remote for KVM. Now for SenServer it's different because SenServer there is a SAPI layer that understands that you can put extra scripts into that SAPI layer and call the SAPI layer to execute the script for you on that particular host. So then SenServer resource can be completely inside management server and does not need to be on the SenServer resource.
はい、ありがとうございます。
Okay.
ビルドしてからの説明は最後のセッションにしてちょっと1時間半経ったんで1回休憩してから今何だ5時半ですね5時40分ぐらいから、始めたいと思います。
Let's see, what type of plugin do we want to add? Let's say I want to add a node element since I talked about it already. So here you have to put a bunch of things about Apache CloudStack. This is going to be used. So what I'm doing here is that I'm creating a Maven project. Right? Its group ID is all Apache CloudStack. That's basically the entire CloudStack project is always under that group. Its artifact ID is DNS-notifier. Actually, I think it's better if I call it because everything else is called by this name. And this version is going to be 4.10 because everything in mainline is called 4.10 right now. And this name is DNS notifier. And it has a parent. And the parent is basically CloudStack bundles. So let's see how far we get. Now we should have a project called this. There's going to be some things that's wrong with it because CloudStack's directory structure is not exactly like Maven's directory structure. I'm not sure why. But we have to make some changes. So the best is to go copy somebody else's changes and make the changes that you need to make. So for example, this one really has nothing. So what this tells us is that in here, the goal to the default goal when you run Maven in this directory is to do install, which basically is a compilation, right? And then there is a source directory called source, and there's a test directory called test. So see, this by default, what Maven does actually is that under the source directory, there's a main directory and there's a test directory. But for some reason, CloudStack decided to go with source and test in the same directory, so we actually have to go and delete that. I'm not sure that's a pure requirement, but for now, that's what we have. So. So now the project is created, and we can start creating sources. So let's create implementation. And we are going to call it to have in place network. So it needs to have and now we're going to add the dependency. So to return true here. So I'll try this. You should actually have a correct parameter, but for now we're going to use none. So now you have to implement the implement class, and we're not going to implement it because we only care when there's a VM coming into the network. So now here we have to implement the prepare class. So our prepare is actually when the VM is coming into the network. So we do want to do this. So we can go with that get IP address. Of course, I don't actually have a DNS to go simplify, but here we will go. But I guess for now, here we're actually just going to block it. Is true. And then when you release, you also want to do the same thing. So here, then you go string, and before you go string address. And string here, then you need to send command to remove the host name DNS entry. Again, we don't care about shutdown, so just return true, so it's okay to shut down. We don't care about destroying the network because we don't care. We are always ready because all we're doing is a logging system. Check on the okay to shut us down because we actually, and this we actually want to return false because we don't have individual services. And verify the services. Okay. So this would be a simple DNS element that you just write. And what this would do, like I said, is that on every entry, it will log this, and it will send a command to the DNS server if I actually know how to write that, to set the IP address and post it. And the same thing here. Okay, so let's see if that actually responds. I actually have to add this. I'm not a Maven expert myself, so what I do is I just copy everybody else's. So does everybody have something in here that you want to add myself? So DNS. Yeah, this is how you know I'm tired. I push Control S and do it. And then let's just double check. So it is called, it's called DNS and profile. And that exception is not mine. I think I was complaining on the mailing list. Somebody else has an exception during compilation. So, while it's compiling, what you want to do is, just doing that is not enough because you haven't added into our components. You haven't told CloudStack that you have these components. So what you want to do is find the network elements. Here's the network element. And you want to add yourself in. Now, once you add yourself in like this, then CloudStack's component location will actually find it and load it for you, and bring it into the network manager. So now we've built. Now, so this is the real shameful part. There's some problems in the mainline to deploy on Windows right now. So I couldn't actually deploy on Windows, so I can't show you how this would work. But you just have to trust me. Let's see. Like I said, I don't know maybe myself very well, so I have to. So this deploys the database from the CloudStack. And then we'll show you running the server, but like I said, unfortunately from Windows, there seems to be some problem with generating the security key right now. Now, somebody must have booked it. People don't actually run Windows, most except for me. So I can't get it to run. The way to get it to run is to run this command. So you can see it's having trouble with Maven running. But we'll see if we have any evidence. So this is a log. So it's having trouble creating the security shell, because the secret key. Oh, and you cannot run sudo. Yeah, that's right. Someone told me about this, because it's trying to execute sudo, and because I'm on Windows, it doesn't execute sudos today. So unfortunately, it could not create that key. And so let's see if there's a way around it. So I know. This would be a perfect time to show you guys. I know the key creation. This is just me just going off and trying to fix it. At least get it out of the way. I know the key creation is done by this guy. I should be able to comment it. Comment it out. So by commenting it out, then because it's no longer in the component stack XML, it shouldn't execute. So let's see if that's the case. Yeah, if it doesn't, then I'm just going to say it doesn't. Is there any questions about what I've done so far? Question?
すみません、ちょっと前のことで、前のセッションのことです。すみませんが、コンポーネント XML に、変えた、例えば HA インバスティネーターとかが、どういうきっかけで呼び出されるかというのは分からなくて、変えたものが、変えてどういうふうに呼び出すのかというのをちょっと知りたいです。ちょっと例として自分最近調べているのが HA インバスティネーターなんですけども、それよく分からないので、もしお時間があれば。
So putting it into components XML causes the HA investigator to be loaded into CloudStack. How to use that particular code is up to the caller of that code. So I can show you how HA investigators are used. else, and generally you can kind of look for it. So, for example, there are various ways to do investigation depending on if it's a VMware hypervisor or if it's a Sun server hypervisor. What happens in Investigator is it actually is used by the HA manager. So you see the HA manager says inject into my list of member variables all the investigators found in component XML. So the component locator then, when it creates the HA manager, would inject everything that is in the component XML. Now, in order to see what it's being used for, you can see it's in this method called investigate, right? And basically, it is trying to investigate whether a host is up or down, and whether a VM is up or down. So during the HA process, HA will be, HA manager gets notified by CloudStack, other code, to say, it will say, oh, this VM's host may be down. And what HA manager is responsible for, and remember I said earlier, HA manager is really automation on top of CloudStack's orchestration. And so it will go through the investigators and it says, can you make sure, can you tell me that this VM is actually down? So it will go through this list of investigators. So you can see it right here. It will ask it, is this VM down? Now, and if the investigator comes back and says, yes, I know the VM is down, then, and so if alive return is false, right? Right here, it says it's false. Then the fence will equal to true. And in that case, then it will actually go through and clear all the database about the, change the state in the database about that VM. And then it will go through and do a start on that particular VM. Now, what if the investigator says, no, I cannot tell what happened to the VM? Then what this guy does is it will attempt to fence it off from this disk. So there is something called a fencer. Right here. If the fence is equal to true, yeah, so if everybody says, I cannot tell whether or not the VM is up or down, then we will go through something called a fencer and ask them, can you fence off this VM for us to make sure that the VM is no longer accessing the database, accessing this disk? Because if we couldn't fence off the VM, we can't start another one. If we start another one, and we were wrong about the VM being dead, then both of the VMs will be writing to the same disk, and it will cause data corruption on the disk. So we have to make sure. And if the fencer comes back and says, I can't fence it off, then what HA Manager does is reschedules this task to be done later. So it does it again and again, just to check whether or not this VM is down or down. So that's how it uses the investigator. So how it uses an adapter is up to orchestration and automation software. It's not really, I mean, it's not, its functionality is defined by that. So it's done at that level. It's not something that you can just look at the code and it says, or just look at that interface and it says, oh, I know how it's being used. You have to look at the guy who's using it. But the interface should tell you how it's being used. But if you want to see exact process, you have to look at that. Okay, let's move on. It's being done by the site-to-site VPN connection down. So I won't be able to start it because someone actually put it into the download to do this, which is quite unbelievable. But that's what it is. I don't know why they would actually put something like this into the data access. Yeah. So unfortunately, I won't be able to start it. But this is basically how you write this element. You write the element, you look at the interfaces that it's supposed to implement. And you try to understand what it's supposed to do. For example, on shutdown, it says the network service provider is being shut down. This should shut down all instances of this element deployed for this provider. And you do the right thing. But if you feel like you couldn't figure out what it means, that means the Java doc on this interface is not enough for you to implement. You should file a bug for that. That's actually a bug, because if the documentation is not enough for you to understand what you should do with this method, then you should file a bug for someone to actually make it a better understanding of what that interface does. And then you just add it to the network, the components XML, and CloudStack will load it. Now, when you do this, if you are a contributor, then it's important that you actually create. Then you want to submit that as a patch. So I actually don't know how to do it because I've never been a contributor. I started being a committer. But let's see how well that documentation is for doing the work. So here you will have to do a git commit. And then you should format this patch. Of course, this patch will absolutely get rejected because I didn't write any unit tests this year. So that's where that is. Or it should be rejected. If it doesn't get rejected, you come to me and tell me what you use. And this is the review board, right? And can I actually add a new review request? Because I'm a committer, so I'm not sure if I can do it. But, yeah, so here you choose the file. It was is CloudStack. And you have that. And so now you can go and create the review request. So I don't want to create it myself because then I'm not actually creating a group. But then that's how you do the creation. Now, the appropriate thing to do is to actually write a unit test. I'm not going to create this. This will fail, right? Because everything is null. But and then you will submit all this into CloudStack. I'm sorry, into the review board. Okay. Any questions? What was going on? Is it totally confusing what I did? Is there anything else you guys would like to see? Okay. So I think that concludes my demonstration. All right. So I didn't quite do it in half an hour, but 40 minutes.
そうですね。はい。今日予定していた、コンテンツというか内容はこれで、終わりたいと思います。まあこれで皆さんプラグインとかガンガン開発してコントリビューションできていけるかななんて思ったりしてるんですけれども、通訳の方もお腹も減ってきていると思いますでも今日はこの辺にしたいと思います。で、まあ最後にですね、来週ですね。